how I would do this problem, okay? Wanting to only read it one time, I would say, hey, 13.8 grams. That's an important thing. I'd probably underline that. It's a solid dry mixture of sodium chloride. I would convert that right away into NaCl, and I saw many of you do this, so I think we're on the same page in terms of our thinking. And potassium nitrate, I would write KNO3 above that. The solid dry mixture was dissolved in 200 milliliters of water. 200 is a distractor. Makes no difference. The moles are going to be the same if you dissolve it in 250 or 300. This is a distractor. This is extra information. The resulting solution was then mixed with an excess. Excess is a key word there, of 0.20 molar silver 1 nitrate. That is AgNO3. The 0.20 molar being in excess, since it's in excess, nobody cares. That's extra information. Okay? Will you give us extra information in problems? Yes. It's your job to say, he mentioned they did this experiment on a Tuesday. I don't know why that's important. Do you divide by 2 on a Tuesday? No. You have to know what's important and know what's not. Okay? An immediate white precipitate formed. The precipitate was filtered and then rinsed with water before being dried in a lab oven for 3 hours. Nobody cares about 3 hours when we're doing the calculation. The final mass of the dried precipitate, that's going to be important. That's going to be important, and you know that. Well, many folks today, when I've observed them, they're doing the NaCl plus KNO3 plus AgNO3 and not really wanting to draw an arrow because they're like, I've never seen three react. There's we've never mixed 3 things. The part that's a challenge that you hadn't been taught yet is to, let's jump down to number 2. I think number 2 might be smarter to come before number 1, but here we go. You're going to want to write so that there's space for 2 rows there under number 2. Hey, we're going to react NaCl, but we've also got KNO3. And we're going to add this outside agent of AgNO3. This outside agent of AgNO3 is going to react. Now, if you look up here at the demo table, you see I've got a 1 liter beaker, and I've got some of these little molecular model ball thingamabobbers. I've got some yellow ones here, hydrogen, I guess, and then I've got the black ones, carbon. Okay? What we want to do when we have a mixture like this, we're going to be very, very selective in what we add to that mixture. What we want to do is add an outside agent that will go into the mixture, and it will only react with one of the components of the mixture. The other is untouched. In other words, I've grabbed the 3 black little carbons here. I've selectively reacted with these, and I'm leaving the yellow ones behind, untouched. So what we do is we write our double replacement reaction, saying, well, I don't know what's going to happen. Well, we know a double replacement could happen. Plus, that's going to be AgCl. And these are all plus 1 minus 1. It's therefore balanced as written, neutral as written. Well, that could be one thing. The other thing that could happen is the second reaction. We're going to do the double replacement and get KNO3 plus AgNO3. We then pull out the solubility chart and we say soluble, soluble, soluble. That's not soluble. The second one, soluble, 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 soluble. You might even recognize, maybe you did, maybe you didn't, in the second equation, the products are the exact same as the reactants on the left side. So clearly there's not going to be a change or a chemical reaction in the second one. So what we can say, we can jump back up to problem number 1, and we can say the precipitate is going to be AgCl. Many of us got that right. Now, we're going to take the chemical reaction that's kind of the business end of things, and we're going to write that. we're going to write that down below, and we're going to say, so the reaction of interest is this one, because this is the only reaction that's actually going to make a precipitate. Okay? That's the only thing that's going to make a precipitate. Oh, let's see. I've got a question. Let's go. Oh, how about Andrew? How you doing? I didn't even know. Super. Here we go, Andrew. Here we go. I have earned this equation, okay? I've earned it. Now, I've got to do some stoichiometry. What is wrong with what I'm about to do, Andrew? What is wrong with what I'm about to do, okay? It says 13.8 grams. What is wrong with this, Andrew? What's wrong with that, Andrew? I mean, it's 13.8 grams, right?
We don't know what 13.8 grams of. We don't know who has 13.8 grams.
Well, it's listed up above, right?
With a solid dry mixture of sodium.
So can I just 13.8 here? Why not?
It says sodium chloride and potassium nitrate.
Right. If you look here at the beaker, excellent. If you look here at the beaker, it's like saying, hey, let's subtract out the mass of the empty beaker. Look, I've got 13.8 grams of sodium. No. That's the mixture mass. We can't get a formula weight of a mixture. I know some of you did, or some of you wanted to. You said 58 and 101, and you added it to, no. So what we have to do is we have to say, I can't use that number. I can't use that number yet. Instead, here's what I know. Stay with me. 19.4 grams, you betcha. That is pure AgCl. That I know. That's pure stuff at the end. So now what we're going to say is, you know what? This is my known. This is my unknown in the world of stoichiometry. We've got to work backwards. And we've done this so many times, I know you can do this. Here's what we're after. Let's get that into moles. And I want to give you plenty of time to work on the other problems. So we got 19.4, and I went with decimals on my formula weights. You wouldn't have to, but I'm going to copy it anyway. That's equal to 0.135 moles of AgCl. It had said up above, we're adding an excess of the AgNO3. So we don't have to worry about that. The limiting is going to control our stoichiometry. We have a 1-to-1 mole ratio, so therefore we must have started with 0.135 moles of NaCl. That's what we must have started with. No problem. I'm a formula weight away from figuring out how many grams that is. It's equal to X over, I used 58.44. When I solve for that, I get X is equal to 7.89 grams of NaCl. Okay. I want to clarify what that means. Our 13.8 gram mixture, as Andrew pointed out, mixture contained 7.89 grams of pure NaCl. So if you want to know the percent NaCl, we're going to say 7.89 grams of the stuff over 13.8 grams of the mixture times 100. And when I did that, I got 57.2%. Okay? 57.2% was this component. If I know how much 1% is, NaCl, we know that the two different components have to add up to 100%. So it's really as simple as 100 minus 57.2 gives me the percentage that was KNO3, or potassium nitrate, problem number 4 on this page. Once we know the percentage of 1, it's like, hey, what percentage of the students in this room are right-handed? Okay, we'll say 75%. Well, then the lefties must make up the other 25%. It's got to add up to 100%, okay? What I'd like for you to do, problem number 5 is a little bit of a thinker. At this point, I don't know if you really need that explaining business. I want you to go right into problem number 2. We've got about 15 minutes to crank out as many of these as we can. I believe it takes at least 3 problems to really start to feel good about this. I have a concern if you kind of shut down early for the long weekend that it's Sunday night and you look at this and you're like, this is my handwriting, but I don't remember why we did what we did. Really, really lock this in. Right now, I can tell you that our next test, in my personal opinion, mixture problems like these are the hardest ones that'll be on our next test.
When is that?
It won't be next week. It will have to be the week after, because I'm going to be out the 2 days next week. Okay? So really, and for some, they've been very encouraged going, this is just kind of stoichiometry and then working backwards. Yeah, but what you have to do, quite honestly, is you have to earn your equation. Okay? Some students have asked this. Really sharp students have said, hey, Bracken, I can kind of read that text up above and I can tell what's going to make a precipitate. Do I have to draw the 2 double replacements, or can I just draw the one that actually makes a precipitate? And the answer is you can go straight to the one that makes a precipitate. Some folks are able to manipulate things in their mind and see it right away. Common question for problem number 2, lead is PB, if you are wondering. Okay.